Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Mathidiso Kongwane, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our today's presentation is on revision preparation for paper 1. Okay, and then now there are topics that fall under paper 1, and then now we are going to look at those specific topics which are meant for only paper 1 with the weightings thereof that is allocated for each topic. So we know that in mathematics the main topic is algebra, and then with algebra grade 12, as we can see that it is 50 plus minus. So on your paper, you'll be having algebra with 50 marks plus minus 3. And therefore followed by the functions and graphs. And then the total weighting for functions and graph on your paper will be 35 marks plus minus 3 with a difference of 3. And then the third topic, we will be having financial growth and decay, and then with finance it is allocated 15 plus minus 3. And then the last topic will be on differential calculus and integration. You know those two, they are always friends, they have an integration in between, and then they worth also 50 plus minus 3 on our paper 1. Those are the weightings and the topics for the paper 1 grade 12. And then now at the back of your question paper, you are having an information sheet, which is a formula with both paper 1 and paper 2, but I'm going to elaborate more on the paper 1 ones. That means immediately at the beginning of your information sheet, of which we call it a formula sheet, it's where you'll be having your paper 1 formula. The first formula there, that is a quadratic equation formula. You know grade 12, that is x equal to minus b plus minus square root of b squared minus 4ac all over 2a. We know most of the case we use this formula in cases where you are factorizing a trinomial or a quadratic equation. And then now we have another formula there, which is x equal to minus b over 2a. And then for this one, grade 12, we know we use this formula when we are looking for the x turning point of a quadratic equation. It must be an equation of ax squared plus bx plus c equal to 0 in order to be able to apply the x turning point in order to be able to apply the quadratic formula. And then now the y turning point still on the quadratic formula, you can take your x and substitute in the original quadratic given to you, or alternatively you can use this formula to find your y turning point value, grade 12s. All right, and then we have exponential equations, and then we know that these ones are having a relationship with the logarithms equations. We know that the original equation for exponential function is a to the power x equal to b, and then as we can see now, we have made x subject of the formula. We know that if you are changing exponential to logs, you involve the log now. And then the equation will change now to a logarithm equation. As we can see now, if you make x subject of the formula, that means we'll be end up with the log b base a, on condition that a must be greater than 0, a must not be 1, and then b must also be greater than 0. And then continue with your formula sheet. We are having formulas that are meant only for finance, growth, and decay. Immediately after the exponential and the log, the formula that you'll be having now, they are of finance, growth, and decay. And then now the first two there, they are only talking to what? Simple interest. As you can see now, your n is not on the exponent. It's a linear equation. Therefore, that one is meant for the simple interest. And then we have the ones that follows after that one with an n as an exponent there. The minute your n is on the exponent, this is now a compound interest grade terms. And then the last formula on finance, growth, and decay, we are having an effective rate formula. That is, effective rate is equal to 1 plus I nominal. Remember that I standing for the nominal interest rate that will be given to you on your statement. And then we have the M and M there, that is talking to the compounding. Compounded monthly, it will be 12, 12 quarterly, 4, 4, and so forth, grade 12. And then this is the formula that we use for the calculation of the effective rate if we are given nominal, or vice versa. If we are given the effective, you can be able to calculate the nominal rate. And then now we have a formula that is meant for differential calculus. The first question on your calculus grade 12 will be requesting you to derive using the first principle. That means this is the first principle formula that you'll be using there. It is f derivative is equal to the limit of h approaching 0, f at x plus h, minus the f at x all over h. And then this is only meant if your question specifically needs you to use what? A first principle. And we know grade 12 where it is demanded that you use a first principle. You can't use any other method. You can't use your rules. It is meant that you must stick to what? First principle to solve that particular problem. And then now we have still on the information sheet the formula that we use for integration. These ones are very important, grade 12. So when you answer your integration, you need to open this part of your information sheet because it needs you to relate to the question in order to be able to select the correct one. We are having 6 of them and then they differ from each other. So you must be very careful in terms of selecting the correct one. So all of these are meant for the integration. All right, and then now we are looking at the key activities now to achieve 30% in technical mathematics, since we know that this is a struggle, grade 12, in order to achieve that 30%. So we are going to now give you the strategy on how can you practice in order to achieve basically the 30%, because our target, we are targeting 100% pass rate, grade 12. The first thing that you must aim to achieve the highest possible PET mark. We know PET is our assistant, of which our target is 80% or more. Ensure that you get that 80% or more, grade 12, on your PET mark. And then the focus content in the table below, when you revise, study for exam, please focus on the following. We are just giving you tips now because we are approaching our exam now. For algebra, we know that the allocated mark for algebra is plus minus 50 marks. But grade 12, if you can just get a 22 marks there, plus minus 22. When you talk algebra, you talk quadratic equations, simultaneous equations, the literal equations, the binary numbers, the exponents and sets. Those are the basics. Can you see grade 12? They hold a lot, 50 marks out of your 150 mark paper 1. And then now for functions and graph, if you can get 10 marks grade 12, 10 marks, then you will achieve that 35% that we are projecting. And then for finance and growth, if you can get a 7 marks plus minus 7, then you will be able to get the 35. Calculus and integration, we are talking 14 marks. And then remember, we need first principles rules on the basic of integration. Remember, integration is easier because the rules are already given for you on the information sheet. Yours is just to relate which one to choose. And then this is basically your paper 1. How to target a 35% grade 12. Because we are focusing on paper 1, I will elaborate more on the paper 1 achieving the 35%. Now let's start with the activities now. Remember, we said algebra is 50 plus minus 3 on your paper out of the 150 paper. Now we are looking at quadratic equations and inequalities. And then now the first one, it's indicated solve for x of the following equations. So the first one, we are given the half x into bracket 2x minus 1 is equals to 0. So the misconception, the mistakes that you are doing grade 12 is that you always try to multiply this back into its original. We do not multiply back if it's an equal to 0. They have already factorized for you on the left. If you are having bracket on the left equal to a 0, that means the left hand side is already factorized for you. Yours is to go straight to the answers. No need to multiply those brackets out, grade 12s. Okay, let's start now. The first one we are giving, we take the first value there, which is half x. We are going to equalize this to 0 because it is already factorized for us, or the 2x minus 1 equal to 0. Can you see that, grade 12? We are now equalizing each bracket equal to 0 there. Then we divide both sides by half, and then we are left with x equal to 0. The half will cancel the half there. 0 divided by half is still a half. Or we have 2x. We transpose a minus 1. It becomes a positive 1. And then we divide both sides by 2. The 2 will cancel a 2. So we end up with an x, which is equals to a half, grade 12s. So that is the answer for your first question. All right, we are still together. And then look at number 2 now. Can you see the difference now? With number 2, yes, we have brackets on the left, but when you look at the right-hand side, there's a number now. Those brackets are now equals to 4. You cannot say minus x equal to 4 as you did with the previous one where you were equalizing to 0. The minute there's a number, therefore you are forced, grade 12, to do what? To multiply your bracket, distributive law of multiplication. So we are going to distribute this minus x into the bracket in each term in the bracket. So it will be minus x multiplied by 6, which is minus 6x. Minus x multiplied by minus x, that is a positive x squared. And then we transpose 4 to the left, because when you solve quadratic equations, your right-hand side must always be 0. And then transpose a 4, it will be minus 4 equals to 0. And then this is the quadratic equation because it is having x to the power 2. So we need to rearrange this in a correct quadratic basic formula there. So the quadratic formula basically is ax squared plus a bx plus c equal to 0. And then can you see the one that is starting is an x squared followed by an x and then a constant number. So we are going to rearrange this trinomial into that format. And then now let's do that grade 12. We are starting with the x squared followed by the minus 6x. And then the last constant is minus 4 equals to a 0. And if you look at this question, there's a message that follows the question. It says round off to 2 decimal places. The minute there is that particular message next to your answer, grade 12, you must know that you do not have factors for that one unless you go quadratic formula. Okay, and then now it is automatically telling you that use a quadratic formula to factorize this. And then now let's go quadratic now. Remember, quadratic states that x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. And then if you look at this quadratic now, it needs the value of a, the value of b, the value of c there. And then now, what is the value of a? A is a coefficient of x squared from the original. And then if we check in this case, our coefficient of x squared is 1 there. Therefore, our a value will be equals to 1. And then the b value is the coefficient of x, which is minus 6 in this case. That means b will be minus 6. And then we have the c value, which is minus 4. Of which is the constant value. Remember, you take the number with its sign, okay? Don't leave those negatives out. Otherwise, you will go wrong grade 12. And then now we are having x is equal to, let's now substitute into our quadratic formula. What is the value of b? Minus 6. But if you look at the formula also have a negative there. So we start with the negative from the formula there. And then now we can now substitute the value of b, which is minus 6. Can you see grade 12? It's negative and minus 6. Both of them must be presented, not only one. Be careful of that one. And then now we are having plus minus. The square root of is the same b value. Then it will be minus 6. Please put in that negative. Squared minus 4. And then the a value is 1. And the c value is minus 4. Another mistake, some of you forget that negative for c there. Please ensure that you substituted correctly. And then all over 2, the a value, it is 1. Then we are now done with the substitution. After substituting grade 12, avoid partial simplification because somehow you do mistakes in terms of the negative signs and so forth. So when you are done with your substitution, you can go straight into your calculator and put in this fraction as it is with its substitution. Then it will take you straight to the answer. Then when you do this together with your grade 12, we end up with an x simple set first. Write it in a simple set first before you write your final answers. That means it will be x equal to 3 plus minus the square root of 13. That is the simple set of this particular fraction. From there, we can now conclude now. Press your SD button or a change button, and then this will give us an x equal to the 6,61. Remember, the statement indicated that we must round to 2 decimal places, or x is equal to minus 0,61. Those are the values of your x values. Big and check your rounding off. It must be correct. It must be 2 decimal places. Remember the third term, if it is a 5 upwards, you add 1 to the previous one. If it is less than 5, meaning 4, 3, 2, 1, 0, you don't add anything, grade 12. So that is the correct solution for this particular question. Okay. Then we move to the third part. If you look at this one, this is now an inequality. It's not an equation, but it's an inequality. To be an equation, you must have an equal sign. In this case, we are talking inequality because the sign is of an inequality, and then of which this one is saying greater than. Okay? So now we are having 2 minus x into bracket x plus 5, which is greater than 0 now. Now with inequalities, grade 12, you must be very careful. If you look at these two here, when you multiply them, they will give you a minus x squared. You cannot have a negative on your x squared. So check your x values after factorizing. They have already factorized for you. Remember, I said if you are having a 0 on the right hand side, that means the bracket on your left, they are already your factors. But we have a challenge with this one because we are having one of the factor having a negative on the x. So that is our starting point. You must deal with that x. Otherwise, it's going to affect your final solution. So we are going to take out a negative 1 from the bracket that is affected by a negative. So when we take out a negative here, we know that negative 1, we don't write that one. You will end up with minus 2 plus x there. So now that means x will change to positive x. So we rearrange in order now. This is now positive x. A 2 that was positive, when you take out a negative, it will now be minus 2. And then we have your x plus 5 that is greater than 0. Can you see that greater? Now we have a negative. Happy, both x factors are now positive. But we have a negative now outside the bracket. We need to get rid of that negative. How are you going to do that? You can divide by -1 or you can multiply by negative throughout. Then when you multiply by a negative or divide by a negative, this inequality sign will be affected. So the left hand side multiplied by negative will end up with x minus 2, x plus 5. But now the inequality sign will now be less than 0 instead of being greater than. Only if when you are multiplying or dividing by a negative. It's only then that your inequality sign will change. Happy now. Our x's are now positive. We can now look at the critical values. The first critical value will be of the first bracket, of which is x equal to 2, or the second one will be x equal to minus 5. We are saying these are critical values. Why? Because we have changed the inequality sign to an equal sign now. We are criticizing them because we have changed the condition of that particular equation. It is normal and inequality. We are giving answers as being an equation. That is why we say we are criticizing them. And then now we go to inequality equation number line. The number line. I know you are having so many methods. Others they use parabola, others they use number line, others they use a table. Use the one that is easier for you, grade 12. Now let's continue. Now we compare your values. You are having x positive 2 and the x minus 3. We are going to start with the smaller one, minus 5, followed by the bigger one, which is positive 2. It must always be like this. Start with the smaller, followed by the bigger one. And then if you look at the inequality sign, it does not have an equal to sign. Equal to 0 is only less than 0. If that is the case, it's an open dot. That means these values are excluded from your solution. And then now, if it is less, now it is closed. Therefore, we shade inside. Okay, they are sharing because now this inequality sign is less there. Okay, become less, you share. We shade in between. That means our x values will meet in between here. So the minute x is in between, that means the solution will also be in between of your x. So we plug in the first x value, minus 5, followed by the second one, which is 2. Therefore, that is the answer for your inequality grade 12. Okay? I hope we are still together. And then move on to number 4. We are still on algebra, quadratic equations, and inequalities. We are now bringing in the log equations. Remember, logs also have equations, and then we have rules that we are following when we are solving the log equations. Now, since we are subtracting the logs here, remember the rule states that if you are subtracting, you divide, right? So we are applying that a log rule now. You will write it as a single log, yes. And then now bracket. Remember, they are both base 10, and this will also be base 10. Remember, if a base is not written, it's your base 10. Now in bracket, because we are subtracting, therefore it will be x plus 2 divided by x. You know the rules, grade 12. We are applying those log rules, and then equals to 1 there. Okay, and then now we want to remove this log. We are now taking this back to its exponential format. Remember, initially we indicated that the exponential equations are in relationship with the logarithm equation. They will always work together like friends. So now we are taking this log back to its exponential form. So now you know how to do that. This 10 will go this side, and then kick that one up to the exponent. So on the left, we will be only left with our bracket x plus 2 over x. And then on the right hand side, we end up with 10 to the power 1, which is still a 10. And then now we cross multiply this x to that 10 and then 1 to that 1. And then x plus 2 times 1 is still x plus 2. We are now simplifying the fractions, cross multiplication, and then 10 times x is 10x. I hope we are still together, grade 12. And then now we take x to the same side, we leave 2 this side, we take this x to that side, it will be 10x minus x. Therefore, 2 is equal to 10x minus x, which is 9x. Then we divide both sides by 9. Therefore, x is equal to 9 over 2. Okay, that is how you solve that logarithm. That is how we solved it. Okay, we are still on algebra. Now, the next question that you remember, the format that I'm following is exactly the format of your paper. That is how they format the questions. So immediately after the inequalities, you will be having your simultaneous equations now. Inequalities, logs, or the exponential equation, you will have your simultaneous equation. And then with simultaneous equation, we will be given 2 equations. The minute we see simultaneous, we know that there must be 2 equations that are involved, with 2 unknowns of which we will be solving them simultaneously. So, right. And then let's look at this now. Yes, we have the first equation, that is y plus x minus 10. And then that is our second equation, the x squared minus xy plus y squared. When you compare the two, you can see that the first equation is a linear one because it's to the power 1. And then the second one is a quadratic one because it is having the exponent 2. And then now the first question states that express y plus x minus 1. That means your linear equation in the form y is equal to mx plus c. Can you see that is having a relationship with a straight line? Straight line is a linear. Okay, now they want us to change this equation here and write it in that format. Make y subject of the formula. That simply means we are going to transpose x and minus 10 to the right so that we can just be left with the y on the left as indicated there. And then now followed by the x equal to x to that side, positive x becomes minus x. And the minus 10 becomes a positive 10. That is all they need, grade 12 for number 1, to change that equation into the mx plus c type. And then number 2, now they say hence. So using the previous answer or otherwise solve for x and y. All right. So if they say otherwise, that means there is an alternative method that you can use except using the hence, using the previous answer. For example, another learner can decide to leave an x and transpose a y and a minus 10, and then work with x is equal to minus y minus 10. That is why it is indicating otherwise. Those 2 learners will end up with the same answer. Okay, now let's start solving the problem now. We want to solve for x and y simultaneously. We can say this was our equation 1, that one was equation 2. We have now created equation 3 there. So we are going to substitute equation 3 into, you can't substitute in equation 1 because this equation was created from 1. So you need to substitute in the one that you didn't use. That means we are going to substitute in the quadratic one. So we are going to substitute equation 3 into equation 2. All right. And then now what is equation 2? Equation 2 states that the x squared minus xy plus y squared, we can transpose that 28 automatically, minus 28 equals to the 0. That is our equation 2. And then now what are we going to do now? Wherever we are having a y, we are going to remove and substitute with minus x plus 10. So let's go to our equation. Oh, we have y. We are going to remove y and substitute, and remove y and substitute. But be careful of this second y. It's a y squared. Don't forget that square. Okay, let's do the substitution, grade 12. And then now we are having x squared minus x, and then y. Oh yes, we are substituting the y with minus x plus 10. Close bracket, we have plus, and then oh, we have a y. Oh, y must be minus x plus 10. And then this is squared. Remember that square is very important. Highlight it greater so that you can remember that it must be squared. And then a minus 28 equals to a 0. Can you see now, after substituting, remember initially here we were having two unknowns on your equation, your x and y. But immediately when you substitute the equation 3 now, can you see now the y has disappeared everywhere? You are now left with one unknown, which is your x. That means that is the method that is making the life easier in terms of solving the simultaneous. Now this is now an equation with one unknown. After substitution, grade 12 is very important. You must be left with one unknown. If two unknowns appears there, that means your substitution is incorrect somehow. Go and check that. Okay, now we are removing the bracket. After substitution, remove the bracket. Simplify your bracket. And then this is x squared. And then it's minus x times minus x. That is positive x squared. The minus x times 10. That is minus 10x. We are done with this product here. And then we move now to this bracket. Remember, this is a square bracket. You can do your bracket normally as you are used to, minus x plus 10 minus x plus 10, because this square means two brackets of the same thing, and distribute them 1 1 1 1, and then you'll end up with the same answer as the method that I'm going to do now. My short method states that you square the first term, that is minus x squared is minus x times minus x, which is an x squared. Okay, minus x times 10 is minus 10x times 2 minus 20x. That is the middle term. And then we take the last term, 10 squared, that is 100. And then minus 28 equals to a 0, grade 12. And then from here now we are going to add like terms. Like terms, they must have the same. Can you see that exponent there? That is x squared, x squared. We are going to add all the x squared. It's 1x squared plus 1, which is 3x squared. We are done with the x squared now. We move to x. We are having minus 10x minus 20x, which is giving us the minus 30x. And then from there we are subtracting 100 minus 28. That will give us a 72 equals to a 0, grade 12. Can you see now you have a trinomial there? And then we can simplify this trinomial by dividing throughout by a 3. If you don't want to do that, remember your quadratic formula will assist you everywhere where you want to factorize a quadratic equation. You can use quadratic formula. X equal to minus b plus minus the square root of b squared minus 4ac over 2a. Or alternatively, you can divide by 3 throughout here to simplify this quadratic equation. 3 will cancel 3, we are left with x squared minus 10x there, because 3 into 3, that is 10 times there. And then 3 into 72 there, we are having 24, and then equals to 0. Right. Now we are looking for factors of 24. When you multiply them, when you add them, they must give you 10. When you multiply, they give you 24, but when you add them, they give you minus 10. Okay, and then now let's check which factors of 24 can give you a minus 10. Remember, when you talk factors of 24, we talk 1, 2, 3, 4, 5, 6, 12, and 24. Those are the factors. Then now we want to look at the prime. 1 times 24, that is your first pair. And then 2 times 12. And then we have 3 times 6. And then and so on, grade 12. But if you look at the, okay, 6 goes with the 4, it's 6 times 4 there. So the working one will be 4 and 6 there. So we have 6 times 4, that is 24. So after identifying the factors, choose the ones that are talking to your trinomial. We have factors of 24, when you add, give you a minus 10. So 6 and 4 are the ones that are working. And they must both be negative because you need a minus 10. You know, a negative times a negative will be a positive. Then therefore, this is x and x there. So the first x value will be equal to 6, or the second x value will be equal to 4. Right. And then remember, you are solving simultaneously for x and y. Solve for x and y. And in this case, we have just solved for x there. And then now we need to find the y values now. So to make your life, don't go anywhere. Go to equation 3, which states y is equal to, because you need a y. So now we take y equal to minus x plus 10. Then we are going to substitute the x value. The first one is minus 6 plus 10. 10 minus 6, which is a 4. Or you substitute your second y value. For x, we are now substituting a 4. It will be minus 4. And then plus 10. And then 10 minus 4 will be equal to 6. Can you see, grade 12, you are now having the y values and the x values. So most of the time you forgot that you are solving for 2. After getting the x values, you stop. Remember, you are solving for x and y. Both values must be there. Right. So we have other type of equations, which is the literal equations. These equations will always be on your paper, grade 12, because they are integrating with your trades. Okay, as you can see now, we are talking the pressure of the hydraulic system here. It is having a relationship with your trade subjects. Okay, it will be an electricity one, electronics or mechanical question that is related to mathematics now. And then now when we talk literal equation, it's equations where we are talking to letters now, solving in terms of letters and so forth, or making a certain letter a subject of the formula. So in this case, we are given the formula used to determine the pressure of the fluid in a hydraulic system, as shown in the diagram below is given. So this is the hydraulic system they are talking to there. And then the formula that is used is the P equal to F over A, of which a P stands for the pressure of the fluid, which is in Pascal, and then the F stands for the force in newtons, and the A is the area in square meters. You know your area is always a square unit. And then now, number 1, they say make A the subject of the formula. They want this A now to be the subject of the formula. Let's look at that, grade 12. Number 1, we were given P is equal to F over A, And then look at, we are working with a fraction. The method doesn't change, grade 12. When you are working with fractions left and right, ensure that everything is written in fraction form. And then we are going to cross multiply and cross that one to that one. And then if we cross A, it will be AP on the left, and then 1 times F will be F. The force, we are talking pressure, force, area, right? And then now, remember, we want A to be subject of the formula. We are going to divide both sides by P here. Then the P will cancel P. We are left with A is equal to F over P. Can you see now? They have swapped the position. A went up there and then P down. So we only have A is equal to F over P there as our equation. That is the solution for number 1. And then number 2, now it will always follow like this. They will give you values for the second one to substitute. And then they say hence or otherwise calculate the value of A if you are given P value as being that 25,984,480.5 Pascal, and the force is given as 25 times 10 to the power 3 newtons. And then they say express the value in scientific notation. If they say hence grade 12, remember they say you can use the previous answer to find your solution. And then if they say or otherwise, you can even go to that original and substitute in that. If you are not sure, basically, if you are not sure about your first solution, we advise you to use the original that is given to you, because if this one is wrong, you are also going to go wrong there. Okay, you are more than welcome, grade 12, to substitute the values on that one and manipulate them until you find the value. Apply your mathematics to find the value of A. And then now let's start substituting now. What is the value? We are looking for the value of A, where we are given F is 25 times 10 to the power 3 newtons, divided by P, which is 25,984,480. Be careful, it's a very big number. You might lose one somewhere, double check. And then from here we are dividing the two values, grade 12. So remember they said leave your answer in scientific notation. We know scientific notation, it's where you're having times 10 to the power sign. Like the fourth here is written in the scientific notation. So they are saying let us leave our answer in that scientific notation. So let's put in this value into our calculators, grade 12, and check what is the final answer there. So our answer will be 9,62 exactly as it appears into your calculator, times 10 to the power minus 4. And then this will be in newtons per Pascal. And the Newton per Pascal is the same as the square meters of the area. Newtons per Pascal is the same as the square. 1 Newton Pascal is equal to 1 square meter. So therefore, those means one and the same thing. All right. Let's continue now. Oh, then we have our binary number. Binary will be tested grade 12. Yes, it's a grade 10 topic. We only do it in grade 10 and leave it there. But when you go to your grade 12 paper, you'll find one question on binary. So there will be a question that is on binary. Grade 12, go back and check your grade 10 work on binary. It will be tested grade 12. Now, in this case, we are given that A is equal to 1,000,111 base 2, and then B is equal to 1,000,11 base 2. And then they say determine the value of A minus B in binary form. So the answer for the first one must be in binary form. Remember the rules of adding and subtracting binaries? Do you still remember them? If we are having a 0 minus 0, the answer will be 0. Okay? When you have 1 minus 1, the answer will be 0. And then when we have 1 minus 0, the answer will be 1. And then when we have 0 minus 1, the answer will also be 1. But for this case, this one is a special case because you will be borrowing somewhere. Since you are subtracting, 0 is smaller than that one. So you need to borrow there to be able to answer the question. But basically, these are the basics that you must know when you are subtracting binary. Okay. Remember, binary is all notation of 0 and 1. You can't have any number except 0 and 1. You can't say 1, 0 minus 1 is a 9. You can't have a 9. You don't have counting numbers in binaries. Binary works only with 0 and 1, grade 12. 0 and 1, that is binary. And then now, number 1, we are having 1. Okay, let me leave a space there. We are having 1, 0, 0, 3 zeros, 3 ones. Let's forget the base for now because we will be busy subtracting. We'll look at that later on. We don't want to be confused, grade 12. And then now we have 1, 0, 0, 1. Let's start noting the value from the right. We have 1, 1, check. It must be underneath each other like that, 0, 0. And then the last one is a 1. That is your 1, 0, 0, 1, 1 binary. And then from here now, let's start now with subtraction. We start from the right, moving to the left, okay? Remember the rule says what? 1 minus 1 is a 0, okay? 1 minus 1 is a 0. 1 minus 0, 1. 0 minus 0, 0. But there comes a challenge now. We are having 0 minus 1. Remember we said it has to do with something being borrowed there. Okay, so look at the method, grade 12. Be careful now, look at the method. Don't confuse this with the subtraction of the natural numbers or whole numbers, okay? Now, we are borrowing now. We can't subtract 0 minus 1 because 0 is small. So we need to borrow somewhere. When we want to borrow from the left, we find a 0 again. We move on. Borrow from the left. Yes, at least we have a 1 there. So we are going to borrow from this one. So when we borrow that one, it disappears there. But here it will appear as 1, 1. Binary method, grade 12, and hope you are still together. The aim is to borrow 1 to this one here. So we are going to borrow 1 here. And then when it comes to this one, when you borrow, it becomes 1, 1. Okay? Now we can now subtract now. A 1 will subtract a 1 there. Then we'll be left with 1. Can you see that, grade 12? You cannot apply your mathematics that you know of subtraction. These are binary numbers. And then we have 1 minus 0. We know the method, it says 1 minus 0 is 1. And then remember, you are left with nothing here because we have borrowed that one. So that is the binary solution. You can now bring down your bases now. This was base 2, base 2. That is the binary solution for that particular subtraction. That is your technical maths. It's so special. This topic is only for you technical mathematicians. And then now number 2, hence. If they say hence, they say using the previous answer. Convert the answer in number 1 to decimal form. Or we are converting this answer now. Our answer is 1, 1, 0, 1, 0, 0. We want to convert this binary number to a decimal number, a number that we know, counting numbers 72, 92, and so forth. And then how do we do that? To convert a binary to decimal, we are using base 2 to the power something. So now our exponents will be ranging from 0, increasing towards your left hand side. So it will be 0, 1, 2, 3, 4, 5, but we start from the right to the left. So now we are starting below the 0. We are having 2 to the power 0 here. We have 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. I hope we are still together now, grade 12. We have written this now in the base of 2. And then where we are having zeros, that one will not give us the values. Can you see that where we are having binary 0, I am cancelling them out. They are not part of our solution. So our final answer will be now 2 to the power 5, which is 32. Correct? Plus 2 to the power 4, which is 16. Plus 2 to the power 2, which is 4. And then when we add those, we end up with what? A 52. 2. So that is our answer, grade 12. So that means this 52 is equal to that binary value there, the base 2. So that is how you change a binary to a decimal number there. Okay. Let's continue now to the next topic. We are looking at the nature of roots. We are still on paper 1, algebra. Can you see grade 12 and algebra is having a lot? That is the topic that is having so many subtopics under it. That is why it is allocated 50 plus minus 3 on your paper 1. So we have the nature of roots. Nature of roots is having a relationship with your quadratic formula. Remember, the quadratic formula says that x is equal to minus b plus minus b squared minus 4ac all over 2a. Can you see now? The nature of roots is using the discriminant is equal to b squared minus 4ac. Can you see that part came from this part here? We can say now, oh, actually the quadratic formula is x equal to minus b if we relate to nature of roots plus minus the square root of the discriminant over the 2a. So the value that is given there inside your square root is your discriminant value, of which it is giving you the nature of roots of what? That particular quadratic equation that you'll be referring to, because a quadratic formula is created from the quadratic equation. So it's now having a relationship with the nature of roots because the discriminant comes from that quadratic formula. Now let's continue grade 12 with our question. We are given that equation Q is equal to 3 plus minus square root of 1 minus 3k over k minus 4. Can you see now our discriminant here? It's 1 minus 3k. Determine for which values of k will Q, number 1, will Q have equal roots. When do we have equal roots in nature of roots? It's when our discriminant is equal to 0. Remember, we have conditions where the discriminant is equal to 0, equal roots. Discriminant less than 0, non-real roots. Discriminant greater and equal to 0, those are the real rational roots. Okay? Real and equal. And then to be rational, it must be a perfect square. Irrational, the value, yes, it is greater than 0, but it is not a perfect square. Then the roots will be irrational. So in this case, we are given that they have the equal root. So we start from the given. Oh, by saying they have equal root, they mean the discriminant is equal to 0. What is our discriminant? We cannot start there, grade 12, because we don't have the actual equation of quadratic ax squared plus bx plus c. We don't have that. But what is given to us is the quadratic formula now. Can you see that? It's from the quadratic formula. So we said what is inside the square root, it's our discriminant. Oh, that means our discriminant in this case is what? 1 minus 3k. This is equal to 0. Remember, we are looking for which values of k will this q have equal roots. Using q, have equal roots. So that means it's minus 3k. We are now solving for k. We transpose 1 to the right, it's a negative 1. Divide both sides by what? By negative 3, because we want that k. Minus 3 will cancel minus 3. Therefore, k will be a negative. Divided by negative, it's a positive. That means our k value is equal to 1 over 3 grade 12. So for which values or value of k, we only have one value for k that suits those particular rules that are given to us, of which is k equal to 1 over 3. The important part is the starting point. Look at the given, start from the given, and then it will lead you to the answer. Number 2, determine for which values of k will q be undefined. Remember, for a fraction to be undefined in mathematics, it's when you are having 0 in the denominator. For example, if I'm having 2 divided by 0, this is undefined. We are not allowed to divide by 0. You can take any number, it doesn't matter how big it is. But if you divide any number by 0, I can take my surname Kongwane and divide it by 0. I will be undefined because the division by 0 is not allowed in mathematics. Now we want to take that information now to deal with this equation. They say, how can we take this equation that is given to us and make it to be undefined? This will only be undefined when grade 12, when your denominator is equal to 0. What is our denominator? That is k minus 4. You are not allowed to divide by 0. That means if k minus 4 can be equal to 0, therefore this equation is undefined. Can you see? We are directed by how can this be undefined? It will only be undefined if this denominator here is 0. What is the denominator? If k minus 4 is a 0. And then solve for k now. Therefore, k is equal to a 4. We have just transposed this to the right. Can you see why we're saying that? If k becomes a 4 here, that will be 4 minus 4, which is giving us a 0. Then that will be undefined. So if k can be a 4, this expression will be undefined. Still on algebra, we are talking exponents and sets. Remember, they can sometimes bring in your logs to simplify. Logs, exponents, and sets can be asked as simplifying an expression, or they can ask you as solving an equation. So in this case, we are simplifying. Simplify without using a calculator. And then we are now going to apply the exponential rules and the sets rules. To solve exponents, sets, and logs, we will use specific rules that you apply to solve those particular topics. Exponents, sets, logs, you use the rules to solve. And then now let's look at the first exponential expression there. It says 7 into 3x to the power 0. Remember, the minute you see exponent 0, there's a rule that says that any base raised to the power 0 is 1. Anything, you can have so much money into your account. You can have $1 million in your account. But if I can take that million and raise it to the power 0, it's the same as just having a 1. Anything raised to the power 0, I can take my name, Matsidiso, and raise it to the power 0. The minute I raise it to the power 0, this will just be 1. So that is the rules of exponent. Now, grade 12, go back to the problem now. We are having a 7, and then this bracket is the one that is raised to the power 0. 7 is not part of that exponent. It's only 3x that is to the power 0. Then this will be 1 because it is raised to the power 0. 7 times 1 is a 7. Done. Can you see that? Isn't it? And then let's move on to the second one. We are given the square root of 8. We are now dealing with sets here. This is sets. And then we have square root of 242 minus the square root of 72. And then with sets now, you need to simplify your set and write it in simplest form before you can simplify. Remember, they say without using a calculator, but your calculator can assist you to tell you when you say square root of 8 in a simple set form. Remember, square root of 8 will be 4 times 2, and the square root of 4 is a 2. Then you'll be writing this as 2 square root 2. Even if you have used the calculator, no one will see that, because we will take your square root 8. If I'm not using a calculator, I'll be doing this. This will be square root 4 times 2. Okay, square root of 4 comes out because we do have square root of 4 is 2. Then what is left in the root sign is 2. Can you see that? I'm writing this here. Even if you test that with your calculator, no one will see that, okay? And then the square root of 242, that one is 11 square root of 2 minus the square root of 72, that will be 6 square root of 2. Same method, grade 12. And then now if we look inside the bracket, BODMAS rule, we always start in the bracket when we simplify. And then now we leave that for now. We are having 11 square root of 2 minus 6 square root of 2. It's like 11 apples minus 6 apples. We are subtracting the same thing. 11 square roots minus 6 square roots. So out of 11, when you take out 6 square root 2's, we are left with how many, grade 12? The 5 square root 2's. And then now we can now multiply, because we are multiplying, there's a bracket there, that is 2 times 5, which is 10. And the square root of 2 times the square root of 2 is the same as square root of 2 squared. So now the 2 will cancel the root sign, we are left with only 2. So that means this will give us a 2. 10 times 2 is a 2 there. Okay, so that is how you simplify that one. Moving on to number 3. This is the exponential expression. But now remember the rules of exponent. When you read them, they always talk same base. Multiplying same base, add exponent. Dividing same base, subtract exponent. It has to do with the same base. But the bases that we are using, they have to be the prime bases. Prime numbers, we talk 2, 3, okay, 5, 7, 11. Out of that bracket of the prime numbers, we are using those bases to simplify the exponents. Remember the prime numbers, the set is 2, 3, 5, 7, 11, 13, and so on. So now when we are solving the exponent, we choose those bases to apply. It must be in its simplest base. You can't just decide that my base will be 4 and so forth. You must check it must be a prime base. It works well with the prime base. Now we are checking our base. Oh, we have 9, we have 27, we have 81. Number 1, we are having different bases. We must ensure that we have a prime base. Can we write 9 in a prime base? Yes, we can use a 3. 3 to the power 2 is still a 9, all right? So we are going to change this 9 to 3. 3 to the power 2. And then remember this 9, it has an exponent n minus 1. Multiply by 27 is 3. 3 to the power what? 12 is 3 to the power 3. Okay, and then now we can even write that 3 to the power 3. Check the exponent there. 3 minus 2n. Bring down the exponent. And then on the denominator, we are having 81. What is 81? 3 to the power of 4. And then bring down the exponents 2 minus n. Can you see now? Everything now is on the same base, which is base 3. In some cases, it will be base 2. Some cases, you'll be having a base 5. So we are using the prime bases to simplify. Happy now? Everything is on the same base. So now the next step will be what? Applying the rule of exponents. That is saying if we are having a to the power x and the y, you need to multiply those exponents. Okay, that is what we are going to apply now. Distributing these 2 to both, that means it will be 3 to the power what now? 2n minus 2. Okay, move on to the next one. Multiply by 3. Distribute 3 to 3 and then 2 minus 2n. 3 times 3, 9 minus a 6n. And then denominator, we have 3 to the power 4 times 2, that is 8. 4 times minus n, that is minus 4n. Can you see that, grade 12 now? Everything is now in base 3, no bracket. After removing brackets, oh, we now apply the rule. Because we are multiplying, there's a rule that says that if you multiply, you add exponent. If you divide, because there's a division line there, you subtract. Or it's like if it changes a position to the numerator, it will change the sign on the exponent. So now number 1, our base will be 3 because we have 3 throughout. On top, we are multiplying, so we just bring those exponents to n minus 2. We add 9 minus 6n as it is. Nothing is changing because we are adding exponents. And then on the numerators, when we take that 8 and minus 4 up, remember you are dividing, the sign will change. You are subtracting. Then this 8 will be minus 8 and the minus 4 will be a plus 4n. Single base now. And then we check the like terms. We are having 2n, still having base 3. 2n minus 6 is minus 2. Sorry, 2n minus 6 is minus 4n. Minus 4n plus 4, that is a 0. So this n will eventually give us a 0. Okay? And then now we have minus 2 plus 9, which is plus 7. 7 minus 8, it's a minus 1. So we end up with 3 to the power minus 1. You can't leave your answer with negative exponent. Remember there's a rule that if it is to the negative 1, it's the same as fraction 1 over 3. So that is the answer, simplified form of that exponential expression. Okay, you can see that we were playing around with the rules of exponent to simplify that one. Still on algebra, we are now looking at the complex numbers. Still on algebra, looking at the complex numbers. And then complex numbers, remember we're talking conjugate, we talk the polar form, rectangular form, we have simultaneous equations where we are solving unknowns and so forth. Okay, and then now the form that we have there is the rectangular form, which says z is equal to 5 minus 5i. That I indicates a complex number. Remember the rules of complex numbers. If I'm having I squared is equal to minus 1. Do you still remember that, great one? The complex number, that means with the complex numbers, when I'm having a square root of negative 1, the answer is I there. It's not non-real as in mathematics. Ne? Square root of a negative number in technical mathematics, it's a complex number. You continue solving. It's only math learners who leave it as being the non-real roots. Okay, great jobs. And then now we are having, we are given a complex number, and then which is written in the rectangular form, which comes from the original z is equal to a plus bi. Okay, and then now first question says write down the quadrant in the complex plane in which z will lie. Right, they say write down the quadrant, they don't say sketch in that particular quadrant. If they say sketch this complex plane in a correct quadrant, then we'll go sketching in that particular. In this case, they just say to us write down the quadrant. So yours is to check. Remember now, in a normal function, the first value here will be x. We want to talk the language that we are used to when we talk Cartesian plane, x and y. So now when we want to elaborate this on a quadrant form, or we can see that the values of x here must be positive, the value of y must be negative. So we go to our quadrant. Remember, x is positive, y positive, there, x negative, the y negative. This says to us, go to the quadrant where x is what? Positive, and then y is negative. X positive, y negative. Can you see that? That was supposed to be sketched in this quadrant. So that means the correct quadrant is quadrant what, grade 12? That is the fourth quadrant. Okay, I hope you've seen how to identify that, the tip that I've just shown it to you now. And then now number 2, it says express the complex number z in a polar form. When you talk for polar form, it's where we are having in degrees and then with the radius. That means we need to calculate the argument and modulus. We talk argument and the modulus. That is the technical math language. Argument, modulus. We don't talk theta as in mathematics. We talk argument and modulus. And then now in this case, we want to identify our argument and the modulus so that we know exactly which values are we calculating. And then let's start now. Remember now this is a and b indicated there, or x and y, we relate to what we know. And then now we are using the formula r squared is equal to x squared plus y squared in order to find that r value there. And then now we are going to substitute the r. This side will lose exponent, then we'll be gaining the square root that side. And then our x here is 5. This will be squared plus the y, which is minus 5. You also square that. And then you put that into your calculator straight to the answer. Then our r will be 5 square root of 2 in the simple set form. Okay, and then now we look at the angle value, and then now we are going to use the tan theta, angle of inclination, tan theta equal to m then. And then now the tangent of theta in this case will be equal to the b over a. And then now what is b over a? B is minus 5 over 5. That means that is the tan of -1. So the arctan of this one, negative, reference will be theta equals to 45. But now we have indicated that this will be in quadrant what? Quadrant 4. In quadrant 4 is where we are having reduction 360 minus. So that means now the real argument value here will be equal to 360 minus the reference, which is 45, and then we end up with the value being 315. That is the correct angle for us. And then now when coming to notation, we'll be having z is equal to the 5 square root 2 into 315 angle there. So that is the complex notation that we are expecting in polar form. That is our polar form of writing that particular complex number given to us. And then number 3, we are solving for m and n, simultaneous equation involving complex numbers now. So now the equation that is given to us here is m is equal to 3i into 2i minus 5 plus 7 minus ni. Okay, as you can see now, we are having a bracket that is disturbing us then. Number 1, grade 12, you must take the unknown except I. If you have another letter except I, you take everything with letters to the left-hand side. So you are going to transpose this minus ni and join m on the left there. Then it will be m plus ni. Unknowns on the left. On the right hand side, then we'll deal with what is remaining here. So the first thing will be removing the bracket. The 3i times the 2i, that will be 6i squared. And then now the 3i multiplied by -5, that is -15i, and the plus 7. Remember that one we have already transposed to the left. And then we are having m plus ni equals to, can you see an I squared there? I've already told you that if you are having an I squared, it's equal to -1. That will be 6. We are substituting -1 for I squared minus 15i plus 7. On the left, m plus ni is equal to 6 times -1, -6 minus 15i, bring down 7 there. Then add like terms on the right hand side, m plus ni there is equal to, okay, 7 minus 6 is 1. Okay, and then minus 15i there. Right, there we are, grade 12. And then from here now we want to identify which value goes with what. Okay, and then now if you look at this now, you can see that the m is the one that is not having I, it will be equal to 1. You just compare your left hand side versus the right hand side, okay? So m will be equal to 1, and therefore the n will be equal to this coefficient because they are both talking to I there. So n will be equal to minus 15. Those are the values of m and n simultaneously. Okay, I hope we are still together, grade 12s. Now we are done with algebra. That means when you reach your complex numbers, that will be your last topic on algebra part. Algebra is a lot, grade 12. Please give that topic attention. It's 50 plus minus 3 on your paper 1. Then we move to functions and graphs. Remember, we are dealing with 4 graphs. We have straight line, parabola, hyperbola, exponential. The last one, we have 5, a circle, semicircle, a positive and a negative one. You must know all of them, 5 of them, grade 12. And then now, given the function, let's look at this one. We are given a function k, which is defined by k at x is 1/3 to the power x and minus 1. The important thing, you must know your original. By just looking at the equation, you must know that it's an exponential graph, this one. So you'll be dealing with exponential graph. And then now the first question says that write down the equation of the asymptote. Remember, exponential is having only one asymptote. They can say the equation of the asymptote or the equation of the horizontal asymptote, because in exponential function we have only the horizontal. We can't take vertical because it will touch the graph. Okay, we have only the horizontal asymptote. So our horizontal asymptote for this one is the y equal to, and then equals to what? The minus 9. Done. That is the equation of your asymptote. And then the question number 2, determine the x-intercept and the y-intercept of k. You know the method, grade 12. It doesn't change in all functions. When you are looking at the x-intercept, you let y equals to 0. So we are going to take that equation. Remember, k at x represents the y for this function, 1/3 x minus 9. And then we let y equal to 0 because we want x, y 0. And then now we have 1/3 to the power x minus 9. Transpose minus 9 to the left, it becoming positive 9. And then we are left with 1/3 x. And then if you look at this, your prime base, exponents, prime base always works for you, right? And then in this case, you can see you are directed by 1/3 that you are going to use base 3. And then 9 in base 3, it is 3 to the power 2. And then 1/3 is the same as 3 to the power negative 1. And then 3 to the power negative 1, negative x, it will be 3 to the power negative x. Can you see you have same base? You can equalize the exponents. Therefore, 2 is equal to minus x. Then our x will be equal to what? The negative 2. All right. X is equal to negative 2. That is our x-intercept there. And then the y-intercept, still on question 2. We are looking at the y-intercept now. Y-intercept, you let x equal to 0. For x-intercept, you let y. For y-intercept, you let x. So now, same equation, y is equal to 1/3 to the power x minus 9. We now substitute an x with a 0. Please do not take that x value that we have calculated and bring it to the y. They do not have a relationship. Ne? Those are the intercept. They are independent. So now to calculate the y-intercept, you must let x equal to 0. So that is why for x, we are now substituting an x with a 0 minus 9y. To still remember your 0, anything to the power 0, 1. Ne? 1 power 0, 1. 2000 to the power 0, 1. That means this is 1 minus 9. Therefore, y is equal to minus 8. That is our y-intercept. Okay? You have your asymptote. You have your x-intercept. You have your y-intercept. So number 3, you need to sketch the graph of k. Clearly show the intercept with the axis and the asymptote. That means you need to indicate all the values into your diagram. If you are saying this is an x-intercept, tell us how much is the value there for both x, y-intercept and your asymptote line. And then let's sketch the graph, grade 12. All right, there we are. We have our Cartesian plane. And then we have calculated this asymptote will be at minus 9. Then we go down there, minus 9. We have our asymptote. Remember, it must be a broken line because it's an asymptote. Remember, asymptote, the graph must not touch that asymptote line. Your graph must never ever touch the asymptote line. It is restricted not to pass that line, not to touch, not to pass through that particular line. And then the x-intercept, you are having x equal to -2, -1, -2. Because it's an intercept, it will be on the x-axis. And then now y-intercept, it must be on the y line, and the y-intercept is -8. And there we have, and then now you can now sketch your exponential function. You must know your shapes, grade 12, it will make your life easier in terms of knowing the exact shape that you are expecting. So this is the exponential. Remember, it must not touch the asymptote, and your graph must not curve back as if it's a C, like it's wrong if it goes like that. It must come closer to the asymptote, but it must not touch that particular asymptote. So that is the correct sketch for that particular graph, grade 12. It's an exponential one. How do we know x is on the exponent? Okay, that means this is indicating to us that if you want to sketch an exponential function, what do you need? Asymptote, x-intercept, y-intercept, only those three. Then you can now have your graph. Right, and then now continuing on functions and graphs. In this case, we are given a sketch now. Remember, previously we were sketching, now we are given a sketch. Sketched below are the graphs of the functions defined by f at x is equal to the minus x minus 4, x plus 2. If you look at this, initially it was x squared. That means it's a quadratic equation. First equation. And then the next one, if it is a fraction form, it's a hyperbola. This one is a quadratic or a parabola. Parabola or quadratic is one and the same thing. This one is a hyperbola function. So that means now you can even predict your graphs by looking at the g function. Can you see is indicated on the hyperbola? It's the f function is indicated on the parabola graph. So what is given to us is A, B, C are the intercept of f. A, B, can you see those are the x-intercept? And C is the y-intercept of f, which is parabola, right? And then A is also the x-intercept of G. Look at A, it also touches the hyperbola graph. Therefore, it's an x-intercept also for a hyperbola graph. And then D is the turning point of f. We have a D point there, of which is the turning point of f of a parabola graph. And then it also lies on the asymptote of G. Can you see a dotted line that is passing through that D? That means point D plays two roles. It's a turning point for the parabola. It's an asymptote for a hyperbola function. Okay, now grade 12, with your hyperbola function, we are having two asymptotes. The first one is the horizontal one. Yes, it will be dotted. But the vertical one is very critical because it's always x equal to 0. As you can see that this is plus 0. There is no number added, therefore it's 0. So that one, it will be x equal to 0. For all your hyperbola function in technical mathematics, the vertical asymptote will always be at x equal to 0. All hyperbola graph technical maths, your vertical asymptote will be at x equal to 0. That means it's on top of this axis here. We can't see it because it is on top of that x-axis line, but it is there as the x equals to 0. And then now the first question, write down the x coordinates of A and B. That means if they say right, that means they are somewhere there. We are not calculating. The answer is already there on our statement. That is why they say right. So now we need to identify, oh, we need A and B. And then if we look at this A and B, those are the x-intercept of a parabola graph. Let's go to the parabola. Oh, yes, they have already factorized for us. That means now for number 1, we can see that we are having a minus x minus 4, x plus 2 equal to 0. Remember, when we remove this, we can multiply and divide by -3, or still we'll have x minus 4 and x plus 2 there equals to 0. And then now, if you look at the first bracket, will give us x equal to 4, or the second bracket will give us x equal to -2. And then now they say write down the x coordinate of A. So you need to tell us, grade 12, which one is for A, which one is for B. You can't just leave them like that, okay? You must be specific now. Then if you relate this to the diagram, you can see that the A is on the negative side of the Cartesian. Therefore, this one will be x for A. And then B is on the positive, that means it will be x for B, that one. Then you have answered the question correctly. So that is why they say right, because learners can see from that this is x equal to 4 and x equal to -2 without doing any calculations. Okay. And the second question there, we are looking at the coordinates of D. Determine the coordinates of D. If we look at D, D is the turning point of a parabola graph. Okay, and we know the formula is that we must use the x equal to minus b over 2a, or you can use your calculus and derive, or you can use your x and y. We have 3 ways of doing this, grade 12. And then let me put in the values. We said a is -2 here, and then we say b is 4. Right. The first method, if you decide to use this formula of x minus b over 2a, you need to multiply this out back to its original quadratic formula. So now our f at x will be equal to negative. We now multiply the bracket, will be x squared minus 2x minus 8, which give us f at x is equal to minus x squared plus 2x plus 8. And then now we can go x is equal to minus b over 2a. Substitute the value of b is 2. That will be minus into 2 there. Over 2, the value of a is -1 from the coefficient there, then into -1. So we end up with -2 minus 2, which is +1. All right, that is the way of finding the x turning point. That is the first method. If you are not applying that one, you can look at the derivative, taking that quadratic equation, and then we derive the equation. Remember, you must remove the bracket first to be a quadratic equation, and then you can derive that. That is 2 times -1 is -2x derivative, and then the derivative of 2x is 2. Derivative of 8 is 0. We are now using calculus to find the x turning point. And then you let it equal to 0, divide by -2 here. On the right-hand side, that will be x minus 1. Can you see that your x will still be equals to 1? That is another way of finding the x turning point. If you are not using that one, you can look at the average. Remember that D is a turning point there. So you can have the midpoint theorem, analytical geometry. You can take the x1 plus x2, x mid, because this is in the middle. That will be the x2, which is 4, plus x1 minus 2 over 2. That will be 4 minus 2, which is 2 over 2 equal to 1. Can you see we are ending up with the same answer there, which is x equal to 1 in all 3 conditions. But now, because we need coordinates of D, not only the x value, you must also calculate the y value for that particular x value. The easiest way, grade 12, is to take this y value and put it on the given equation there. We look at F1 now. Where we have x, we are going to substitute 1. We avoid substituting in between our calculation. We might have gone wrong somewhere, so it will affect our answer. The best way is to go for original. So f at 1, that will be 1 minus 4 into 1 plus 2. And then now this will give us the y value that is equal to 9. So the coordinates of D in coordinate now, it will be 1 and 9. That is the point there, it's 1 and 9, grade 12. I hope we are still together on that one. Okay. Moving on. The third question, Determine the numerical value of k now. We are talking to that k. Remember, we have the turning point here, which is 1 and 9. We have a minus 2 there. We have a 4 there. All right. And then now they say determine the numerical value of k. K is in this hyperbola equation there. So if we have that unknown k, if we can get this value and that x and the q there, we will be able to find k. Okay, remember this g at x stands for y. So basic calculators, we are having y is equal to k over x plus q. But now, happy enough, if you look at that asymptote, remember is the value of q, the asymptote, it is passing at y equal to 9 because we have calculated with the turning point. Oh, we know that the value of q, it must be 9. So we will substitute 9 for q. And then you need to check for another point that is on the graph, that on the G graph, on the G graph, because we are talking the G graph there. A point on the G graph that will be substituted for y and x there. And then if we look at this checking, then we can see the only point that we have is that one, the point of A. Right. And then A is having coordinates what? X is minus 2 with the y 0 there. Happy now, we have x and y values there, then we'll substitute x and y, and then we are having our asymptote q equal to 9. Oh, q is 9. Oh, happy now. We have that value, we have something to substitute there. We can now easily work out our solution. Let's start substituting. What is the value of y? Y is 0. The value of x minus 2. The value of q 9. Okay, and then now we substitute 9 to transpose 9 to the left hand side minus 9 k over minus 2. Remember fractions, we are cross multiplying, minus 2 to that one. It will be minus 9 times minus 2 equal to k. What is the k value? Positive 18. So if we were asked to write the equation for g at x, we will be saying now, because that is the possible question, determine the equation of g. So this is the method we are following, but we must conclude that now the equation of g at x will now be equals to 18 over x plus the 9 for the value of q. That is the actual equation for that. All right. And then now determine the values of x for which g graph will be less and equal to 0. Number one, you need to understand what do we mean about this. When we say g less than equal to 0, we say go to g graph, okay? Look where g is less than 0 mean you look where the graph is negative and where the graph is equal to 0. Those are the two conditions. Less than means negative, equal to 0. Now you go to your graph grade 12. You are going to identify now the g function. We are on g, the hyperbola one. All the graphs below the x-axis, where y is negative here, they will be negative. But our focus now is on g, right? Above, the graph is positive. Above, the graph is positive because it is now talking to the y value that is positive this side. Okay, that means they are controlled by your x-axis. Below the x-axis is negative, above it is positive. Now we want to identify for which values of x will this graph be negative now. Oh, our graph is negative at this point here. Can you see? It's only this part here. So this part lies between which values? The x value minus 2 and 0. Okay, after identifying, you now tell us, oh, this graph will only be negative between 0 and minus 2. That is where we are having a negative part there, between minus 2 and 0. Can we now include minus 2 because 0 is included there? Can we include minus 2? Yes, we can. Can we include 0? No, remember there's an asymptote for that particular function which is on top of this x-axis. We cannot put an equal to here because now there is an asymptote on x equal to 0. Asymptote means the graph will never touch that particular point. Okay, grade 12. This brings us to the end of today's session, which was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. We wish you all the best till we meet next time.